history of brick making can be traced back to the dawn of human civilization, revealing a development that is both intricate and gradual. Evidence suggests that the earliest bricks were produced as far back as 7,500 BCE in regions where the availability of natural resources, specifically clay and mud, coincided with communal patterns of settlement. Archaeological findings from sites in the Middle East indicate that early inhabitants utilized their environment to create durable materials, employing a simple but effective technique involving the mixing of clay with water and then forming it into blocks. These rudimentary bricks were not fired or baked, but were left to dry in the sun, creating what is known as sun-dried or adobe bricks. The process of sun-drying clay blocks involves shaping moist clumps of clay into rectangular forms, usually by hand or with rudimentary tools. Once shaped, these blocks were placed in sunlight for several days, depending on the climate and weather conditions. As the sun dried the bricks, the moisture evaporated, resulting in a solid, yet not wholly robust structure. The dryness conferred some degree of firmness, sufficient for the construction of temporary homes, walls, or other simple structures. Communities ranging from Mesopotamia to parts of Egypt began utilizing these items, which could easily be mass-produced at a manageable pace. As urbanization progressed, particularly in regions such as Mesopotamia, a change in the brick-making process occurred. By approximately 4000 BCE, evidence indicates that methods became more sophisticated, including the introduction of firing techniques. The act of firing bricks involves subjecting the raw clay to high temperatures in a kiln, which alters the properties of the clay and significantly enhances the strength and durability of the final product. This transition towards fired bricks marked a pivotal development in construction technology, leading to architectural advancements. The kilns utilized for firing bricks varied in design, typically consisting of simple upright structures made from mud or clay. These early kilns were often circular or oval in form, with a narrow opening to allow for the introduction of fuel to maintain the necessary heat for firing. Different fuels, including wood and other organic materials, would have been utilized in these primitive kilns, which made it feasible for communities to produce fired bricks in larger quantities. In the ancient city of Ur, situated along the Euphrates River, fired bricks became prevalent around 3000 BCE. The architectural structures from this period, including temples and ziggurats, showcased the potential of fired bricks as a primary building material. Complex structures were erected using these durable materials, enabling the construction of more elaborate civic and religious buildings. The use of fired bricks permitted architects to design spaces that were not only larger but also more intricate, fully exploiting the compressive strength provided by this innovation. As the desire for increasingly durable construction materials spread, regions around the world began adopting and adapting brick-making techniques that catered to local environmental and cultural conditions. In ancient Egypt, for instance, the bricks were largely produced using mud from the Nile River, which was easily shaped and then sun-dried. The Egyptians utilized both sun-dried and fired bricks in their monumental construction, with the latter primarily reserved for the impressive tombs and temples meant to withstand the test of time. Buildings such as the pyramids of Giza testify to the legacy of their brick-making skills. The versatility and adaptability of bricks as a building material extended into the civilizations of the Indus Valley, with cities like Mohenjo-daro and Harappa showcasing the strategic use of fired bricks in urban planning. These cities, dating back to approximately 2600 BCE, exhibited advanced drainage systems and public baths, all constructed from standard-sized fired bricks. The uniformity in size and shape facilitated more structured urban architecture, revealing a sophisticated understanding of engineering and building techniques that would remain influential for centuries. During the period of classical antiquity, the prominence of bricks began to spread further into regions such as Greece and Rome. The Greeks initially relied more on stone for their monumental structures, but soon began employing bricks, especially in areas where timber was scarce. Romans took this practice several steps further by not only using fired bricks extensively, but also incorporating them into their concrete, creating a composite building material that reduced the reliance on quarrying stone. The introduction of the use of concrete along with brick led to innovations in structural design, such as vaulted ceilings and arches, significantly influencing the architectural landscape of the period. In somewhere between the 2nd and 1st centuries BCE, practices relating to brick-making were meticulously documented within Roman architectural texts, such as those by Vitruvius, which emphasized the importance of quality in the materials produced. The Romans established extensive brick kilns across their empire, indicating a highly organized system for brick production. Some of the earliest bricks produced in these Roman kilns bore stamps, indicating the maker and the date of manufacture, establishing a form of quality control that ensured the standardization of the product. Such practices laid the groundwork for future industrial processes. In the centuries that followed, particularly during the medieval period, the development of brick-making witnessed further evolutions as European architecture began to favor stability and permanence over the light structures of previous centuries. The advent of Gothic architecture inspired substantial changes as vast cathedrals and castles required robust materials. The introduction of large fired bricks into construction techniques at this time allowed builders to create massive, vertically oriented structures encompassing features such as flying buttresses that dispersed weight and afforded intricate designs. The expertise in brick production itself became increasingly sophisticated, with the introduction of various molding techniques, glazing processes, and innovations in kiln designs. Brick makers began experimenting with different types of clay to produce bricks with varying aesthetic qualities and structural characteristics, leading to the emergence of decorative bricks that were employed in revetments and facades. The Renaissance reignited interest in the classical ideals of architecture and underscored the importance of brick as a building material. The combination of artistic aesthetic and structural integrity found in the firing of bricks revived the popularity of previously established techniques, alongside the development of new approaches and styles that stretched across Europe. With the Industrial Revolution in the 18th and 19th centuries, the brick-making industry underwent significant transformations. The introduction of mechanized production allowed for the mass production of bricks at unprecedented rates. Innovations in firing methods, including the steam-powered continuous kiln enabled the production of a uniform product that could cater to rapidly growing urban populations. Furthermore, the advent of new materials such as Portland cement began to influence the brick industry, as builders sought to combine the properties of bricks with the advantages of concrete. The history of bricks cannot be isolated to mere advancements in technology and production methods. It also encompasses the socio-economic factors that shaped societies. With the rise of urban centers, the demand for building materials surged, affecting the scale and scope of brick production. In many regions, brick making became a community enterprise, with families and neighborhoods banding together to create necessary materials for housing and civic structures. Cities around the world began to reflect the evolving identity associated with brick construction, showcasing a tapestry of color, style, and texture in the urban fabric. From the red bricks emblematic of English industrial towns to the rich earth tones seen in Mediterranean architecture, bricks have always carried with them the characteristics of their geographical origin. The adaptability of brick continues to play a role in modern construction as technological advancements pave the way for innovations that reevaluate traditional brick applications. Architects and builders today utilize bricks not only for their structural benefits, but also for their aesthetic versatility, aligning with contemporary environmental considerations. As the story of bricks weaves through time, it intertwines with innumerable cultures and societies, each contributing their own narrative to the ongoing legacy of this ubiquitous building material. The journey of brick making remains rooted in a fundamental human impulse to shelter, create, and innovate within the ever-evolving landscape of civilization. An exploration into the subsequent epochs of brick history presents opportunities to delve deeper into how these basic building blocks have continued to redefine architectural possibilities across time and geography. The materials and techniques used in the construction of ancient bricks exhibit a considerable diversity rooted in geographical conditions, cultural practices, and the technological advancements of the time. Throughout various ancient civilizations, principles of brick making were established through trial and error, leading to methods that were refined over countless generations. Clay constituted the principal material for brick making. A fundamental component of earthenware, it is formed from the weathering of rocks and minerals over geological time. The types of clay used in brick production varied depending on the soil composition found in different regions. For instance, alluvial soils, which are deposited by rivers, typically provide a fine-grained clay ideal for producing bricks with uniform quality and desirable properties. In contrast, clay from volcanic ash or weathered granite might result in a rougher texture. The manipulation of clay involves several critical steps. Initially, the raw clay is extracted from the earth, often through manual digging or the use of simple tools. This process generates large clumps of unrefined material that necessitate further preparation. After extraction, the clay must undergo a process of wedging, which entails kneading the clay to remove air pockets and inconsistencies, ensuring a homogeneous mass ready for shaping. Once adequately prepared, the clay is formed into brick shapes. This can be achieved through various techniques, two of which are the molding process and the hand-formed method. In the molding process, wooden or clay molds are utilized, allowing for multiple bricks to be shaped simultaneously thus expediting production. Alternatively, hand-formed bricks made by artisans are shaped directly through the application of pressure and manipulation, often resulting in irregularities that signify handmade craftsmanship. Following the molding phase, bricks must be dried to facilitate a subsequent firing process. This initial drying occurs naturally under the sun, and it is essential to reduce moisture content gradually. Rapid drying can lead to uneven shrinkage and cracking. Thus, bricks are typically left to air dry for several days, depending on environmental conditions such as humidity and temperature. Natural sunlight serves as a primary drying agent and is important in many regions where the climate is favorable. After sufficient drying, bricks are subjected to firing. This critical step enhances their structural integrity, durability, and water resistance. The firing process traditionally occurs in kilns, where controlled high temperatures are employed. Ancient kilns come in several forms, including updraft, downdraft, and periodic kilns, each distinguished by the manner in which heat is circulated. The effort to achieve the right temperature is crucial, with the most effective range often being between 900 and 1,100 degrees Celsius. At these temperatures, the clay undergoes vitrification, wherein the minerals within the clay bond and solidify to form a robust brick. The fuel sources used to maintain the firing temperature in kilns significantly affected the brick's final characteristics. Common fuels included wood, coal, and other organic materials, each imparting its unique properties to the finished product. Wood-fired bricks, for instance, may exhibit variations in color, influenced by the specific type of wood utilized and the combustive quality of the fire. The advancements in brick-making techniques appeared to correlate with evolving architectural styles and economic conditions. For example, during ancient Egyptian times, bricks were often produced in standard sizes for use in the construction of imposing structures and functional buildings. In constructing monumental edifices such as temples and pyramids, uniformity became imperative, underscoring the efficiency of mass-produced bricks. Ancient Mesopotamians, as well, are known to have produced sun-dried bricks using the same methodologies, but often for different purposes. Their architecture relied heavily on mud bricks due to the abundance of river clay. The resultant structures, including ziggurats, demonstrated a unique ability to withstand the forces of nature. Yet the undulating terrain and frequent inundations led to challenges, compelling builders to innovate various preservation techniques, including the application of bitumen as a binding agent to enhance water resistance. In the Indus Valley Civilization, another notable ancient culture, brick-making practices adopted a more scientific approach. Archaeological excavations in cities like Mohenjo-Daro and Harappa reveal standardized brick dimensions, approximately 7.5 centimeters by 15 centimeters by 30 centimeters. This uniformity signifies an organized method of production, indicative of a sophisticated understanding of construction and urban planning. Furthermore, the pressing technique employed in brick formation appears to have allowed for a more precise and consistent product, contributing to the robustness of structures throughout these ancient urban centers. Transitioning to the Americas, the use of adobe, a sun-dried brick variant, was prevalent among ancient cultures such as the Pueblo peoples. Adobe construction involved mixing clay with straw, or other fibrous materials, resulting in insulation-efficient bricks capable of maintaining temperature within dwellings. Intriguingly, unlike fired bricks, adobe structures require comprehensive maintenance to combat natural erosion and wear over time, creating a dynamic relationship between the inhabitants and their built environment. In the construction realm, specialized type of bricks known as fired bricks gained prominence during subsequent historical periods. Represented by their resilience against the elements, these bricks became increasingly desirable for structures subjected to inclement conditions. Early Roman innovations in kiln design led to an expansion in both the quality and quantity of fired bricks during the height of the Roman Empire. The Romans embraced masonry techniques that leveraged fired bricks in aqueducts, defensive walls, and public buildings such as baths and temples, contributing to monumental architectural achievements that would define their civilization. Meanwhile, in ancient China, the use of fired bricks developed alongside advancements in kiln technology. Chinese brick production began to flourish as the tangential relationship between clay and firing techniques became better understood. The Chinese employed dragon kilns, which are characterized by their elongated design, facilitating the production of vast quantities of bricks in a single firing session. This efficiency allowed builders to create intricate structures, including pagodas and the walls of the Great Wall, which served military and economic functions. When examining the continued evolution of brick materials and techniques, it becomes an intricate narrative of human adaptation, environment, and cultural exchange. Local customs and available resources directly impacted brick-making practices, leading to distinctive regional variations. Over time, the adaptation of techniques and materials paved the way for innovative building solutions, driven by an intrinsic desire for durability, coherence, and aesthetic appeal in the constructed environment. The history of brick-making is complemented by a broad spectrum of auxiliary materials, such as lime and mortar. Lime, when combined with clay, acted as an adhesive that contributed to the structural integrity of both ancient and modern constructs. The skillful blending of different aggregates illustrates an advanced understanding of material properties, ultimately enhancing the performance of brick as a fundamental construction element. In light of these interactions between various materials and techniques throughout history, ancient brick making stands as one of the pioneering forces shaping architectural tradition across continents. Each civilization adapted and evolved its practices to address specific regional challenges, demonstrating a nuanced understanding of materials science long before modern methodologies were established. The legacy of ancient brick-making, intertwined with the story of humanity's development, remains intrinsically tied to the evolution of construction practices and the persistent pursuit of human ingenuity in the built environment. The process of industrialization marked a significant shift in the production of various materials used in construction, not least of which was brick, a fundamental building material that has been utilized for thousands of years. Prior to the onset of industrialization in the late 18th century, bricks were primarily produced using traditional methods, which often involved manual labor and rudimentary technologies that varied significantly based on geographical and cultural contexts. The transition to an industrialized approach to brick production revolutionized the way bricks were manufactured, distributed, and utilized in construction projects around the globe. As industries began to adopt mechanized processes to enhance productivity and efficiency, brick manufacturing was no exception. In England during the late 1700s and early 1800s, mechanization led to accelerated brick production. The adoption of steam-powered machinery facilitated the creation of more uniform bricks compared to their handmade counterparts, allowing for a standardization in size, shape, and quality. This development was particularly beneficial as it catered to the rapidly growing urban populations that required substantial amounts of housing and infrastructure. The introduction of the brick-making machine, a pivotal innovation in this period, enabled the mass production of bricks. One such machine, known as the brick press, was capable of producing a stack of bricks at a significantly faster rate than manual production methods would allow. The brick press operated by molding a mixture of clay and water, which was then compressed into brick-shaped forms. This mechanized method increased output while simultaneously reducing the labor required for brick making. The ability to produce large quantities of bricks consistently had ripple effects on the construction industry as it allowed builders and architects to plan and execute larger projects with greater scalability and predictability in material availability. Simultaneously, advancements in kiln technology, such as the move from traditional beehive kilns to more efficient updraft ovens and tunnel kilns, played a crucial role in revolutionizing brick firing methods. Traditional methods of firing bricks were often labor-intensive and time-consuming. The introduction of more advanced kiln designs enabled more efficient use of fuel, improved heat distribution, and reduced the overall firing time required to achieve the necessary hardness and durability of the finished product. The result was a more reliable output that met the rising demands of the construction sector. The factor of transportation also underwent significant changes as industrialization progressed. The expansion of the railway system facilitated the transport of large quantities of bricks to urban centers where demand was surging due to population growth and industrialization. The previously limited geographical distribution of brick manufacturers expanded to regions well beyond their local markets, broadening the scope of brick use in construction. This newfound ability to transport bricks over long distances encouraged builders to adopt bricks as a primary construction material, even in regions where they had not been the traditional choice. In addition to the advancements in production and transportation, the rise of urbanization during the 19th century created a considerable shift in architectural styles and preferences. As cities grew in size and complexity, the demand for reliable, durable materials that could be produced in large quantities grew. Brick emerged as a favorable material due to its myriad advantages, including its durability, fire resistance, and relatively low cost compared to stone or other building materials. These properties made brick not only practical but also architecturally appealing, as evidenced by its prevalence in urban construction. The notion of a brick city became synonymous with progress and modernity, paving the way for a resurgence in its popularity. The intertwined nature of industrialization and brick production led to the establishment of large-scale brickworks. These facilities employed thousands of workers, transforming local economies and contributing to the labor market across various regions. The economies of scale that emerged in brick production encouraged competition among manufacturers, which ultimately resulted in lower prices and increased accessibility for builders and construction companies. The emerging middle class sought to own homes constructed from these affordable, mass-produced bricks, further stimulating demand in the housing sector. Additionally, the advent of chemical engineering during the 19th century had notable implications for brick production. Innovations in materials science permitted the development of specialized bricks for specific applications, such as refractory bricks intended for use in high-temperature environments like furnaces and kilns. This diversification allowed the brick industry to cater to a wider range of construction needs, further entrenching its role as a fundamental building material in various sectors. At the turn of the 20th century, advancements continued to be made, including improvements in the properties of bricks through the exploration of new materials and additives. For instance, additives such as lime and fly ash began to be incorporated into brick production, which enhanced certain characteristics such as workability, durability, and resistance to environmental factors. The introduction of these modified bricks expanded the applications where brick could be utilized, from load-bearing walls to intricate facade designs. Into the mid-20th century and beyond, the rise of modernist architectural movements began to reflect a changing attitude towards building materials, including bricks. While certain architectural trends shifted towards prefabricated elements, concrete, and glass, bricks retained their importance in modern construction. Architectural innovations such as the minimalist style saw a resurgence in the use of bricks, though in more stylized and artistic manners. The modular nature of brick construction offered architects the ability to play with rhythm, texture, and patterns, fostering creativity even within the bounds of a traditional material. The post-World War II rebuilding efforts across Europe and the United States further propelled the brick industry into a new era. Vast housing shortages required rapid construction, and the scalability of brick production proved instrumental in meeting these demands. Furthermore, the post-war economic boom allowed for greater investment into manufacturing technologies, which fueled innovations in brick firing technologies and improved quality control processes. Globalization began to weave its complexities into the brick industry as well. The international exchange of materials and technologies paved the way for cross-border collaborations in brick manufacturing. Countries that had traditionally been reliant on their own local materials now had the opportunity to incorporate bricks from distant locations. This exchange not only diversified the types of bricks available for use in construction, but also led to changes in architectural styles as influences from various global regions began to blend. As the 21st century approached, issues related to sustainability, environmental impact, and energy efficiency became more prevalent in discussions surrounding construction materials. The brick industry, facing scrutiny regarding its environmental footprint, began to adapt. Innovations such as the development of eco-friendly bricks that utilize recycled materials or the designing of bricks that improve thermal efficiency emerged. These changes reflect an ongoing commitment to evolve and meet the challenges posed by contemporary environmental concerns. Despite the prominence of alternative building materials and modern construction techniques, bricks have managed to retain a significant place in the industry. The continued exploration of new production techniques, designs, in sustainable practices demonstrates the resilience and adaptability of the brick industry. This adaptability is potentially a direct response to an ever-changing market, one that balances tradition with the innovations that emerge out of necessity and inquiry. In examining the narrative of bricks within the framework of industrialization and mass production, one can identify a common thread that weaves itself through the evolving methodologies and the resulting impacts. Brick, as a building material, continues to serve as a canvas for architectural expression, while also adapting itself to the constraints and imperatives dictated by new technologies, cultural shifts, and ecological considerations. Thus, the interplay of tradition and modernity represents an ongoing dialogue within the brick industry that remains crucial to its sustainability and relevance in contemporary construction practices. The evolution of brick usage in construction has undergone significant transformations over the years, particularly in contemporary contexts where sustainability has emerged as a focal point. The integration of sustainable practices in the brick industry is increasingly becoming prevalent. This section examines current trends, technological advancements, and practices that aim to enhance the sustainable qualities of bricks while also considering their environmental impact. Bricks are traditionally made from clay or other natural raw materials. The process of manufacturing bricks has evolved from rudimentary techniques to sophisticated industrial methods. Historically, the production of bricks involved shaping wet clay into rectangular forms and allowing them to dry in the sun. While this method is still employed in some settings, modern production has seen the transition to the use of kilns. These kilns facilitate controlled firing of bricks at high temperatures, resulting in enhanced durability and structural integrity. The heating process used in brick production consumes a considerable amount of energy, which has prompted the industry to seek alternatives that are more energy efficient and environmentally friendly. One such trend in the brick industry is the development of energy-efficient kilns. These kilns are designed to optimize fuel consumption, minimize emissions, and enhance thermal efficiency. Traditional kiln designs, such as the downdraft kiln and the updraft kiln, have been subject to innovation to improve their overall performance. The adoption of technologies such as regenerative kilns has allowed manufacturers to recover some of the energy used during the firing process, thus reducing the overall carbon footprint associated with brick production. In addition to innovations in kiln technology, manufacturers have also shifted towards the use of alternative materials in brick production. The incorporation of industrial byproducts, such as fly ash from coal combustion or slag from steel production, into the manufacturing process is notable. These alternative materials can replace a portion of the raw clay used in brick making. By utilizing waste products, manufacturers can reduce the demand for natural resources while also diverting these materials from landfills. This practice ultimately contributes to a circular economy within the construction sector. Recycled materials have gained traction as a sustainable alternative in brick making. For example, crushed concrete and reclaimed bricks can be processed and reformed into new bricks, providing an effective method for repurposing waste materials. The mechanical properties of recycled bricks often match those of their virgin counterparts, thereby promoting their use in both structural and aesthetic applications. This trend aligns with the increasing emphasis on resource conservation and waste minimization in construction practices. Furthermore, the environmental benefits of sustainably produced bricks can extend beyond the manufacturing stage. The energy efficiency of bricks contributes to the overall sustainability of buildings. Bricks, when used in construction, can regulate temperature due to their thermal mass properties. The ability of brick walls to absorb and slowly release heat helps maintain a stable indoor climate, which can reduce the reliance on heating and cooling systems. As a result, sustainable brick production is linked to energy conservation in the buildings they comprise, further amplifying their eco-friendly profile. Moreover, the aesthetic versatility of bricks has led to their widespread usage in modern architecture. Architects and builders often choose bricks to achieve desired textures, colors, and patterns. The development of new glazing techniques and surface treatments has expanded the design possibilities for bricks, allowing them to be utilized in contemporary facades and landscaping. This aesthetic adaptability caters to consumer preferences for visually appealing structures while maintaining sustainable construction practices. Despite the advancement of sustainable practices, the brick industry still faces challenges, particularly concerning the environmental impact of clay extraction. The mining of clay for brick production may result in land degradation and biodiversity loss, if not managed responsibly. To address these issues, companies are increasingly adopting sustainable sourcing practices. This includes actively engaging in land restoration initiatives and ensuring that clay is procured from responsibly managed resources. Such practices fall in line with broader sustainability goals and demonstrate a recognition of the ecological consequences of brick production. In ongoing efforts to promote sustainability, there has been a concerted push towards developing bricks that enhance green building certification ratings. For example, bricks may contribute towards achieving LEED, Leadership in Energy and Environmental Design, certification, which recognizes buildings designed with sustainable features. Certifications can incentivize manufacturers to adhere to environmentally friendly practices, resulting in a more sustainable industry overall. Research organizations and academic institutions are also engaged in the investigation of innovative brick materials with enhanced sustainability properties. For instance, recent studies have explored biocomposite bricks that incorporate organic materials such as hemp or straw. These biocomposite bricks are lightweight, possess insulating properties, and may facilitate better environmental performance. The exploration of alternative raw materials serves as a testament to the brick industry's commitment to evolve in response to sustainability challenges. With the paradigm shift in construction practices, the concept of green bricks has gained traction. These bricks are specifically designed to minimize their environmental footprint by incorporating eco-friendly materials and sustainable manufacturing methods. Some innovative formulations of green bricks utilize a lower firing temperature or alternative binders, such as lime instead of cement. Such alternatives can substantially reduce the energy required for brick production while maintaining physical performance standards. The proliferation of digital technologies also plays a role in the future of the brick industry. Advanced manufacturing techniques, including 3D printing, are being explored for their potential to revolutionize how bricks are produced and to further emphasize sustainability. With 3D printing, it becomes feasible to create customized designs and shapes while minimizing material waste.